and hopefully I'm going to get that finished up today. And what I've just, like I said, what I just handed out, I took what was left of Chapter 2 and condensed it a little bit, because some of that information, it's stuff that I was like, you know, you're really, that's, we need other stuff. So that's why I chose the other stuff that I did. The point that we left off last week, we left off talking about energy. We didn't really get into it a lot, but one of the things that we're going to learn as we go through the course, we're going to learn that energy is going to happen in our bodies in different ways. The way that we get our energy, we consume it. We eat our foods. When we eat our foods, we're going to learn that we eat our fats, which are lipids. We eat our sugars, which are carbs. We eat our proteins, which can come to us in different ways. So energy and thinking about our bodies. It gets a little interesting, so to speak. We talked about how we build molecules and we break them down. We talked about when a molecule is built, energy gets stored. When a molecule breaks down, energy gets released. We mentioned that we have tons of chemical reactions occurring all the time in our bodies, because as these processes occur, that is taking place all the time. And as we build molecules and break them down, that was noted as being our metabolism. Does everyone remember that term? Now, we'll talk a little more about that, but just a recap on energy. Whenever energy is stored in a bond, okay, for example, what happens when we make a molecule, that is the potential to do something, okay? So that means potential energy. If we break the bond and we're using that energy, that's kinetic. That's energy in motion. When we are doing or moving, think about movements of your body. Think about those skeletal muscles moving our body. That's mechanical work. Chemical work, now gets a little bit interesting. Just mentioned so chemical energy. All right, how many of you had breakfast this morning? Oh, most important meal of the day, okay? Even if it's just grabbing the Pop-Tarts or whatever the case might be, okay? Very important meal. Do you happen to know why I'm saying that? Do what? Okay, it will help start our metabolism after we've been asleep all night. And we need to replenish materials that our body has been using all night long. Do you happen to know what takes place in your body as you sleep at nighttime? Hold up, do what? Yes, we have chemical reactions occurring, but this is also the time that your body can repair itself. So any type of cellular repair, if you might have a cut or a scrape or whatever, it's the time that your body is doing maintenance. And it does require enough sleep, okay? I can't remember if we talked about sleep. No, it's my part 2 class. How many of y'all get that recommended? 8 hours a night. That's what I saw a lot of my students in my 142 class shaking their head no. And I'm like, no, we got to get those 8 hours a night, okay? It's so important. And so this is the time that those materials that we took in, okay, that we ate, all right, that might have gone into short-term storage, all right, they get to be used. And that is a good thing for the body. When we have energy used, when we're carrying out this metabolism, have you guys ever heard of the first and second laws of thermodynamics? Okay, the first law tells us we cannot create nor destroy energy. All right? We simply change its form. For example, okay, so my breakfast consisted of all 3 of those foodstuffs. I had the lipids, I had the carbs, I had the fats. All right? Right now, the processes that are taking place in my body, the carbs that I took in, they were complex. So my body's working to break them down to give me little glucoses so the little glucoses can go and give my brain energy, give my nerves energy, give my muscles energy, and that sort of thing. The lipids that I took in, they're getting broken down. They're going into my bloodstream so that they can make their way to the cells so the cells can use them to make membranes, for example, the cell membrane. Those proteins that I ate, the body's breaking those down into their component parts, which are the amino acids, and those amino acids are going to make their way through the bloodstream to a cell that needs them, and they're going to be used to make proteins. So my body's busy doing that right now. However, all those chemical reactions that are occurring, they are giving off energy and heat. When we break those chemical bonds give off heat. Now, this heat energy is one of the reasons we get to maintain our body temperature. I saw an article this weekend, and I was so glad to see it, because I have always taught that they, meaning some people who determined somewhere in a setting somewhere, that our body temperature, the average, or the norm, I should say, the norm is 98.6. Finally, article comes out this weekend going, that might not be the case. teaching that for 20 years. 98.6 is an average, okay? I could have a body temperature that's 97, and that's completely normal for me. You could have a body temperature of 99. That could be completely normal for you, okay? Not everybody is 98.6. I've always thought that, you know, but anyway, good to see that article this weekend. Now, here's the reason that those bonds, as they're broken for these molecules and so forth, that when they're broken and energy is giving off, the second law of thermodynamics tells us when, and number one, if we cannot create nor destroy energy, we can only change its form. That tells us there is never 100% transfer of energy. Meaning, think about if my breakfast was 220 calories, which is the energy we use to measure for food. I don't get all of that in energy in my body because some of it's given off as heat. All right? So, in our bodies, what is our energy molecule?
Calorie.
Well, that's our energy in a foodstuff that we take in. But like I just mentioned, all of those pieces that are making up the lipids, the proteins, the carbs that I ate, okay, they have to get to the cell for the cell to use them. And for the cell to use them, we make our energy in the mitochondria. We can make it in the cytoplasm. It's not as efficient, but as long as we're not doing some huge type of physical activity, do you guys remember the mitochondria ended producing ATP? Do you happen to remember what that stands for? Adenosine triphosphate. Now, what that's telling me in the structure that we see, I have my adenosine, and 3 phosphates. Okay? Do y'all remember earlier in the chapter talking about trace elements that are important? Phosphate was one of them. Okay? This is one of the reasons why phosphate is important. Now, in its form with 1, 2, 3 phosphates, this is a high energy molecule. That means it can go anywhere in the cell where it is needed to supply energy. Why would a cell need energy? Okay, if we now are you thinking the cell itself from one cell to become 2 in reproduction? Okay. Yes, we will need energy for that cell to do the mitosis that you're probably thinking about.
To sustain homeostasis?
We need it to make sure, because don't forget, homeostasis isn't just on this huge level of the body